Hi guys, we are still on solution to NABTEB GCE November 2023 examination. This is a continuation to the video. So the first video is already on this channel, so you can watch the video and then continue from here. We are still on Best Science Brain YouTube channel. We are going to 3BII, the main paper question. A wave has an amplitude A, makes two complete circles in a time t. Alpha question, draw a graphical representation of the wave. Beta, if the wave travels a distance s, write down an expression for its wavelength. Solution, so this is the graph required. A plot of y in meters, that y stand for vertical displacement, against time on the horizontal as the time in seconds. And then we'll have two circles or two oscillations covered in a time of t seconds. And the horizontal distance covered is s meters. So you can take a look at the question and also take a look at the diagram given to you. Then there's no mistaking it. Then the B part says we should find if the wave travels a distance of s, write the expression for the wavelength. So the wavelength is given by, you have been derived as equal to s over 2. So this is the expression for the wavelength of the wave. Wavelength or lambda equal to s over 2. We'll now go to question 3C that says state three defects of the eye and their corresponding corrections. Three defects of the eye and their corresponding corrections. Solution, we had the myopia, short-sightedness, corrected by the use of concave or diverging lens. We have the long-sightedness, otherwise called hypermetropia, corrected by the use of convex or converging lens. We have the astigmatism, corrected by the use of cylindrical lens, and so on. We have equation 3D. An equilateral prism has a refractive index of 1.6. Calculate the angle of I minimum deviation, 2 refraction at minimum deviation, and 3 incidence at minimum deviation. So we'll go to the solution now. So going to the solution, 3DI, this is a prism. You can see it's an equilateral prism. The angle at A should be 60 degrees. Angle at B 60, angle at C is also 60. We see the incident ray and angle of incidence. We see R1, which is the angle of incidence, angle of refraction on the face AB. R2, angle of refraction on the face AC. E, angle of emergence, and small d, the angle of deviation. We'll now move to the solution. The first we have to calculate is angle of minimum deviation. Taking that relationship, writing this n equal to sine dm plus a over 2, everything enclosed in bracket. That sign covers the numerator, all over sine a over 2 in bracket also. Substituting, our referring index is 1.6. We now put 1.6 equal to sine d plus 60. Angle A is 60, is equilateral prism. Well, we now replace our dm with d. You see, okay? All over 2 equal to all over sine 60 over 2. We now solve. If you divide sine 60 by 2, get sine 30. We now make multiply 1.6 times sine 30. That gives us sine d plus 60 over 2. Solving, sine 30 is 0.5. So 0.5 times 1.6 gives us 0.8. That gives us sine d plus 60 over 2. Then bring out the sine. D plus 60 over 2 now becomes sine inverse of 0.8. And that gives us 3.2 degrees. we'll cross multiply so that we can make D the subject. So D plus 60 now becomes 2 times 53.2, that gives us 106.4. We'll now make D the subject. D now becomes 106.4 minus 60, making D the subject of the formula. So as you can see there, you made it the subject of the formula. The answer now becomes 46.4 degrees, with the angle of minimum deviation. Then going to 3DII, we're looking for the angle of refraction at minimum deviation. At minimum deviation, the two angle of refraction, R1 and R2, become equal to each other. So R1 becomes equal to R2. Then going by geometry, 2R equal to A, because two interior angles of a triangle is equal to an opposite, is equal to an exterior angle. You can go back to the diagram and look at it. So you make R the subject. R now becomes A over 2, which is 60 over 2, which is 30 degrees. Then going to 3D triple I, we're looking now for the angle of incidence at minimum deviation. So we use Snell's law. Find this equal to sine I over sine R. We make sine I the subject, which is N times sine R, which is going to be sine I equal to 1.6 times sine 30. Solving it, 1.6 times sine 30, 0.5 give you 0.8. Then I becomes sine inverse of 0.8, which is 53.2 degrees, which is the angle of incidence at minimum deviation. Number 4A says draw a large label diagram of an electric bell and explain its operation. So we're not going to look at this question because of its bulky nature. So we'll try to concentrate on the calculation aspect. So you can read it off from a good textbook. We'll now go to number 5A. We're given a diagram of two capacitors in parallel. 2 microfarad and 3 microfarad connected to another one in series, 5 microfarad in series, and then a PD or 70 volts is applied between the combination capacitors. And then we are told from the circuit diagram above, calculate I total capacitance of the circuit. I electric charge in the 5 microfarad. If the potential difference across it is 40 volts. I energy stored in the parallel combination. So we go to the solution. For the solution, first of all, combine the parallel combination, which is the 2 and 3 microfarad. We'll combine them by addition, 3 plus 2 giving us 5 microfarad, which is equivalent to, in SI unit, you can still put in SI unit if you wish, but not yet time for that anyway. So we are first combine the capacitors in series, in parallel, 2 plus 3, that give you 5. Having done that, we'll now take everything together using product over sum. That is, we'll now have these 5 here represent the 2 in parallel, the 2 of them combined, while the other 5 is the other one in series. So we'll call this one, the combined one, C1, call the other one C2. Then use reciprocal formula, or you use the short cut, C1 times C2 all over C1 plus C. That is 5 times 5 all over 5 plus 5. That gives you 25 over 10, 2.5 microfarad, or in SI unit, 2.5 times power minus 6 farad. So that is the total capacitance of the system. We now look at 5AII that says we should find the charge stored by the 5 microfarad in capacitance in series. So looking for Q. So the capacitance in question is the one in series, which is 5 microfarad. And in SI unit, it's going to be 5 times power minus 6 farad converted to SI unit. The voltage across that particular capacitance in series is given to us in the equation as 40 volts. Applying the formula C equal to Q over V, making Q the subject. Q becomes C times V, and then substituting 5 10 power minus 6 times 40, we have the charge as 2 10 power minus 4 coulombs. So this is a charge stored by the 5 microfarad capacitance that is in series. The next question is 5A. Let me get the question. 5A triple I. We also find the energy stored by the capacitors in series. Capacitors in series are these two 2 microfarad and 3 microfarad capacitors. So energy stored by a capacitor given by E equal to half CV squared. Then what's going to be our C in this equation? Our C will now become the total capacitance. Those in parallel, we look at it as CP, which is 2 plus 3, 5 microfarad, or 5 10 power minus 6 farad. That's the total capacitance of the two in parallel, what you use here now. Then what's going to be our voltage? Our voltage will no longer be 70. The 70 volts is a PD across the 3 capacitors. But we are told in the question that 40 volts is the PD across the 5 microfarad that is in series. So the PD across the two that are in parallel are going to be 70 minus 40, giving us 30 volts. So applying all this in this equation and substituting, our E becomes half times 5 power minus 6 times 30 squared. Solving, our E becomes 2.5. 2.5 is half of 5. 2.5 times power minus 6, then times 900, which is 30 squared. And that gives us 2.25 times 6 power minus 3 joules. So the energy stored by the capacitor that are in parallel. The next question, 5BI, says explain photoelectric effect. Solution: this is a phenomenon where light, typically in the form of photons, striking a metal surface, causes the emissions of electrons from the metal, full stop. If the energy transferred from the photons to the metal is above the work function of the metal, electrons are emitted. This is just a further explanation anyway. Then going to 5BII says define the term threshold frequency. Solution: this is the minimum frequency of incident radiation required to eject a photo electron. I said photo, not photon. So that photo, there's a hyphen or before electron, photo electron, without imparting any additional kinetic energy. I repeat, I say this is the minimum frequency of incident radiation required to eject, or you can say remove, a photo electron without imparting any additional kinetic energy. Then 5C, a light of wavelength 5.0 times 10 power minus 8 meters is incident on a metal surface, full stop. If the work function of the metal is 3.0 times power minus 19 joules, calculate the I frequency of the light to, or II, energy of the incident photon. Bracket, take the speed of radiation C as 3.0 per 10 power 8 meter per second. H, that the Planck constant, as 6.6 power minus 34 joule second. Solution to CI. We have frequency as C over lambda. That C means velocity of radiation. So the value of our C is 10 to the power 8 in bracket given to you. The value of the wavelength of the radiation given to you also in the equation as 5.0 power minus 8. So inputting the values and then solving, we'll have 0.6 times 10 to the power 16 hertz. Convert to standard form, we'll have 6.0 times 10 to the power 15 hertz. Number 5C, we have to find the energy of the incident radiation. We use the Planck equation E equal to HF. H is Planck constant 6.6 to the power minus 34 times 6 times 10 to the power 15. Solving this out, we're going to have 3.96 to the power minus 18 joules as the energy of radiation. Look at the equation. They mention work function in the equation, and we did not use the work function in this problem because it's not relevant for this solution. So we have come to the end of the first part of NABTEB, solution to NABTEB, November GCE 2023 physics. Always stay connected to the channel for more videos. If you're not subscribed or if you watch this video, do us a favor by subscribing. Go to the channel's name, Best Science Brain, up, and then under it, you see the subscription button in form of a tiny bell. Tap on it once and get subscribed. Whether you're writing WAEC, O-level, GCE, NABTEB, internal examination, or you are an A-level student, high institution, we'll introduce high institution topics soon, and very soon we'll be teaching topics for high institution A-level. Always stay connected to the channel. Wish you best of luck.